Hello, everybody, and thank you for joining us on this third session and final session of our medical device cybersecurity series. My name is John Gomez. I'm the CEO and founder of Sensato. And with that, we're going to kind of jump into this session. For those of you that are new to this, we'll give you a little bit of background. But for those of you that have been kind of playing along all along, I want to be respectful of your time and really get into the context. So this program really was designed because we continually see that there's not really one set of best practices or frameworks related specifically to medical device cybersecurity. So we really wanted to kind of develop at least some form of education for people where they could use this as a way to think about their own medical device cybersecurity programs and where they may need to evolve things, or maybe they're exceeding the best practices, or what we would consider best practices. So probably the best way to use this program is almost kind of a just-in-time audit. As I mentioned, this is the third in a series. The first program went through compliance, the second one through detection of threats and anomalies, and this one we're focusing on incident response. And so hopefully it gives you this opportunity to think about, are we doing this? Are we not doing it? Are we doing, better, cooler, more mature things than what are being presented here? So hopefully it also helps you evolve your skill set and creates also a professional awareness across our industry, and we help each other kind of think about what we could be doing better from specifically medical device security. So as we talked about when we first kicked this session, this series off, there's really three things we're continually trying to do. At least this is what we do as an organization each and every day. And first of all is assure that not only medical device security, but all cybersecurity programs are able to comply with best practices and regulations. Secondly, that you're able to detect threats and anomalies within your environment. And thirdly, respond to those things in a professional and timely manner. And today we're going to be talking all about response. We've covered the first two in the first two sessions, so we'll reference some of that in material, but really want to focus on response. Ultimately, because of what's at stake here, which is potentially human life, one of the other areas that we need to address proactively and continually when we think about medical device security and all cybersecurity, frankly, is how do we reduce liability and increase our legal defensibility. So, obviously we want to defend our networks and our assets and the humans connected to it, but ultimately we want to make sure that what we're doing is legally defensible and we're making good, smart, proactive decisions. So with that, I want to kind of establish some foundation, reorient us back to some of the things we may have mentioned in the past, and talk about how that impacts us from a response perspective. So there were two noble truths that we have introduced in the first series and first part of this series, the first session, that have carried out, and this becomes, part of really today's presentation is underlines this, maybe underscores, I guess is a better way to say, this first noble truth of medical device security, that many organizations just deploy software and call that a medical device security program, but hopefully you've been learning as we've gone through this that is not true, right? Deploying software alone, regardless of what vendor or how good the vendor is or their product may be, that is not enough to consider a medical device security program. And again, today's session will really hopefully bring that to bear. The second kind of noble truth is that there are no real regulations or best practices, whether we're thinking of things like HIPAA or NIST or other things that really address a standard for what we need to be doing day to day to protect humans, right? We are probably most comfortable in protecting data because that's what our cybersecurity legacy has been. But now when we add humans and the protection of humans, which are patients, this becomes a very different mindset that we need to embrace. And so we'll talk again more about that as we go through today. So I want to step back and give you some background on things we've observed related to incident response. We run a lot of tabletop simulations. And so one of the things that is interesting for us is the ability to observe people respond to complicated simulations. By complicated, we don't mean that they're very technically complicated, but that we've added stressors, right? what we're trying to do in any tabletop simulation is to determine the organization's tipping point. At what point does an organization no longer become effective in responding to an incident? So we've had well over 1,000 people attend our simulations, many hospitals, as you can see, that have gone through them. And so that is also complemented by the amount of incidents that we've responded to, which is actually much more than 50 at this point. And so we've tried to kind of sit back and think about what are all the common things we see across all of these organizations. And we kind of have this list of items. And the first big key point for us is that, ultimately what we observe is that organizations, when we throw human safety issues into the equation of a cybersecurity simulation, become challenged in terms of how do they prioritize and what do they do. And most of that is because we don't see many best practices or playbooks related to how do you protect human life. So, if we dive into this a little bit more in a more detailed manner, where we really kind of take things point by point, these are the kind of critical observations that we've made when we're observing an organization go through a tabletop simulation, or even in a real incident where they call us and they tell us, hey, we think we've got an issue here. So the first thing that we find typically is that in most cases, the incident response program is really, and we've kind of mentioned this, focused on protection of data, right? We're very comfortable there. And when you read through somebody's incident response plan, it's very easy to see that, they've really thought about this from how do I protect against malware, and how does that impact my domain controller, or how does it impact my VPN? And so it's very IT oriented, and that's fine. And that's been the kind of the threat landscape we've lived under for a very long time, but that threat landscape is changing and evolving. The second thing we find is that when we add stress, when we create high velocity or high stress situations in a simulation, within about 15 minutes, to sometimes as much as 20 minutes, we will see that all policies, practices, playbooks, all of the things that have been developed by the organization to respond to a situation are thrown out the window. What we see is, rather than people focusing on using the playbooks and the policies and procedures that they assumed they were going to be using, things become very ad hoc very quickly. And there's a lot of reasons for this that we don't have time to go into today, but a lot of it has to do with the emotional and psychological aspects of incident response, which is something that most organizations do not think about. We'll talk a little bit more about that as we go through this, but that is a very key part of how do we respond to something that involves patient safety if we don't have the emotional context to or mindset to do that. Muscle memory is rarely relied on when we're watching these kind of situations. And by muscle memory, we mean that people can respond to a situation without having to really think through what they're going to do. We really need them to act swiftly in a consistent, high quality manner. So we don't see a lot of organizations that have muscle memory in responding to a very serious incident. We've talked about the emotional, psychological. The other thing is we see most organizations don't appreciate the audacity or the sophistication of the attacker. This has become such a big challenge, I think, for not just medical device security, but all forms of cybersecurity across many different industries, so much so that we put together a 6-part series on really representing the attacker's perspective and the audacity. And if anybody here wants access to that, let us know, and we can give you a link to all the recordings of that program. But we get into what I believe to be some real sophisticated views on how attackers operate. And the reason we do that is because when we're thinking about incident response, if we don't really understand and respect the attacker, we can't really defend against them. We underestimate what their capabilities are. And when we go through tabletop simulations, we find this because we often hear people say, well, would they really do that? Would somebody actually do this or do that? And you start realizing there's not a real clear understanding of who your enemy is. The other, and this is a big one, is that many of the incident response programs we see that are based in terms of classical IT and not focused on like medical device security are very hierarchical. And I think this has to do with just generally how IT organizations run. In most cases, you have a situation where, if somebody calls the help desk, they then have to call somebody else, and then that person has to call somebody else, and they have to call somebody else, and that hierarchy continues. And this is for a non-security issue. But unfortunately, that type of hierarchy moves over to the security world. And when we're thinking about medical device security, that's a very dangerous practice to have that level of hierarchical requirement for authority to take action in place. And we'll talk more about how these things kind of can be addressed as we go through the rest of this. But these are kind of the big observations. And the problem is, obviously, if these things are occurring, they break down our ability to respond effectively in what we consider a timely and professional manner. And that then leads to patient safety issues. So we're trying to figure out how do we develop and deploy an incident response program that is focused on patient safety and ultimately allows us to respond in a professional and timely manner. And we're going to share with you some of those ideas through the remainder of this session. So cybersecurity tactical incident response. We abbreviate that CTIR, and the easiest way to kind of remember that is CEDAR, right? That's and quite frankly, this is a term that we created and a program that we created. But I want to kind of differentiate it from, the word tactical from classical incident response. And I think this is important because as an organization, you need to be asking yourself, are we really set up to do classical incident response, or are we really thinking from a tactical perspective? And so I'm going to spend a little time trying to help give you some insights into each of those terms. And even if you're not technical and maybe you're more on the clinical engineering side, or you're in neither of those, you're more on an operational side attending this presentation, I think it's important to kind of differentiate. So classical incident response, at least the way we're defining this, is focused on preservation of data. Right, the real focus of that incident response program is, hey, somebody's attacking our systems, and we assume that they're after data or they're trying to shut down our systems. And so we don't really account for attack violence and velocity, which we'll talk a little more about, but we've mentioned in this, I believe we've mentioned throughout the series, the concern with that. And it's very typically process plan driven. This is where things like playbooks come in and hierarchy, and there is an appropriate need for this. So you shouldn't throw out the baby with the bathwater. We shouldn't say, well, classical IT or classical incident response doesn't work anymore, let's get rid of it. There is a time and place for that. And typically that is in any situation where there is no patient safety issue, right? You don't have life at stake. So we actually encourage that you continue doing whatever you're doing for classical incident response, but you call it out as, hey, this is more data-focused incident response, if you prefer that term, or non-patient safety incident response, or whatever you want to call it, but call it out as to, this is not the right way to respond to an incident that involves patient safety. The one thing we do recommend to people is, if you don't know what type of attack you have, if it's something that is focusing on patient safety or could ultimately cause patient safety issues, and if you're not sure of that, then you start off tactically, and until you can prove that there is no patient safety issue from this type of cybersecurity event, you then, once you can prove that, you can then go back to your classical approach to incident response. So I just wanted to spend some time to kind of frame out, at least from my perspective, when I look at incident response programs, how do I categorize and quantify them? So that kind of also brings us to this issue of response versus recovery. The important thing here is that I've seen all too often where, as part of classical incident response, we kind of intermingle disaster recovery or business continuity, and those are truly separate things. And I don't mean this from a academic perspective. I mean this truly from how you design your IR plan. Your IR plan should know exactly where things end, whether classical or tactical, and not get involved in how do you recover the environment. And we'll talk a little more about this, but it's important that we think about the fact that once we've contained or prevented further spread of the attack, then we're done with that response. And theoretically, we go back and get ready for the next response, right? Now, some of us have very limited resources, and 1 second you may be thinking response, the next second you may be thinking recovery, and that's quite all right. But what we want to do is make sure we address both those skill sets, and we don't end up doing both those things at the same time, because you'll end up having a bigger patient safety issue than just focusing on response or just focusing on recovery. So when we put these things side by side, if we need a little cheat sheet and we think about tactical incident response is focused on high velocity attacks. Anything that's moving very quickly through our environment is the first test, right? We can ask ourselves, this is a fast moving attack. Yes. Okay. We probably should take a tactical position on this. The second thing is attack violence. Is this impacting humans, right? And we can change either one of these. We can ask first, are we impacting humans? Does this attack impact human life? If it does, then we're tactical. The other last piece of this, is this an in-progress attack? Is the attack occurring right now as we speak? And if it is, chances are we want to be tactical. Classical are for things that have no real velocity to them, right? So the attack has occurred in the past. There's no human impact to it. It's a contained attack to maybe one asset like a laptop, or maybe it only impacts one server or one application, but we can contain it, or it is contained. And so we kind of separate our ability to choose which model we want to use for response based on these symptoms. But it is important that we choose. And again, we preach the fact that if you don't know which one you have, then go tactical until you can prove otherwise. There's no need to be tactical. And I'm going to give you some kind of like, okay, what does it look like when you're being tactical? Because for a lot of you, this is very new. And all of this that we're presenting to you today in this module is bleeding edge, right? These are probably not things you'll hear from other companies or other experts in the field. And a lot of this just comes from us having to deal with these things and having to quantify it into some model. So I'll give you some specifics on, okay, what's it like to be tactical? What do you need to be thinking about as we go through this? So we've talked about and mentioned attack violence and velocity. And so we need to kind of quantify that. The purpose of thinking of attack violence and velocity is pretty simple at its most foundational level, which is that we need to understand how quickly the attack is moving, and are we prepared for high velocity attacks, and what kind of violence is the attack creating. Now, violence is not always just about impacting human life. It could be tertiary, so we could have situations where the attacker is attempting to destroy equipment. If you look back at the NotPetya malware that was released years ago, that was a cyber munition, right? It wasn't trying to create ransomware. It wasn't just locking systems down. You pay a fine or pay a ransom, and then it unlocks. The attack behind NotPetya was truly simply to just destroy systems. And no matter what you did, you couldn't reboot them, you couldn't replace them, you couldn't go out and get a new motherboard. NotPetya was a very destructive piece of malware. So back then, when that happened, we started thinking in terms of attack violence. And so we carry that forward to today and forever more, that we need to think about attack violence and velocity when we're thinking about incident response. And this is kind of a cheat sheet for you, in that one of the very first things you can think about with your incident response plans you have today is kind of talk about a roundtable, in your organization, that how much violence and velocity would your plan be able to withstand? It's a great conversation to have, and will help you quickly understand whether you need to augment that plan or start thinking about how do you specifically deal with high violence, high velocity attacks. This concept of velocity really had brought us to this concept known as the critical success target. And some of our clients have thought, hey, this is a better term for that, would be a critical success window. Right, they have this window of opportunity to kind of respond and contain or prevent the attack. And if you don't do that within this critical success target or window, then you're probably in recovery mode. The attack's already occurred, and you're no longer trying to contain and prevent, you're just in recovery mode. And that's why earlier I mentioned we need to have this kind of dividing line, right, where our mind is thinking, I'm in recovery, I'm in response mode, and now I realize, nope, the hacker succeeded and I'm in recovery mode. And then when we're thinking of medical devices, specifically in patient safety, that is a very critical distinction, right? Because recovery mode could mean that we're in a situation where we have to evacuate patients. We have to bring in additional clinical staff. We have to replenish certain drugs because they have to be refrigerated. It's for effectiveness, and our refrigeration systems are out. So I'm mentioning that because there was a situation that occurred within the past few months that I won't get too specific into because I don't think is very well known, where organizations infrastructure was hit. It wasn't medical devices. It was actually HVAC systems, and took out all of their air conditioning systems, which led to a very serious situation for that organization because they were without air conditioning in the middle of a heat wave for, I believe it was a period of 7 to 8 days. Now, they were able to get some air conditioning back up and running, but they had to, again, evacuate patients and think about medications. So I'm just giving you this. I want to make sure we all clearly understand response versus recovery. And when we're thinking of response, we're thinking of this critical success target or window that we have. And if we don't get our job done, our response program, if we can't respond within that critical response window, then we switch over to recovery. So what is the critical success window? It's not just some arbitrary thing. In most cases, you're going to be looking at about 14 minutes. From the moment the attack launches to the moment you're able to contain or prevent it, you have about 14 minutes. And there's a lot of reasons we use that number, 14 minutes. Now, there's just historical learning of how quickly, again, this is for high violence, high velocity attacks. Obviously, if the attack's not moving very quickly, you may have more time. It's not very violent, you may have more time. But when we think about worst case scenario, what does our incident response plan have to be able to support? And what's our goal? What's our objective? This is the critical success window. This is what you want to get to. Now, some of you may be in a position where you're like, we just don't have the people to do that. What if it's 3 o'clock in the morning? I don't even have people around that would be able to respond to this in 14 minutes, let alone during the middle of the day. So you can pick a different window, right? You could say within your incident response plan, well, our critical success window is to contain or prevent all attacks within 30 minutes or 45 minutes or 60 minutes or whatever you think you can really do. And then you work towards that. And once you're able to do that and get to that point with a simulation and with testing yourselves and training, then you can change that. You can say, okay, our critical success window right now is 60 minutes. If we can change a couple of things, maybe we can get to 45 minutes. And maybe you'll never get to 14 minutes, right? Maybe you'll never have that kind of resourcing. But the important part here is you have a conscious conversation, because at some point, remember, we need to think about how do we reduce liability and increase legal defensibility. And this is a very, very serious topic when we add the context of a human life and, being in a situation where we get deposed and have to explain why it took so long to respond, or why weren't we responding faster, or whatever it may be. We need to figure that out now, not 18 months after an attack when lawyers are grilling us. So that's kind of the ultimate critical success window. Again, you may or may not be able to make that, but that's one thing to think about, right? So you have two pieces of homework, if I may. One is, can your plan withstand a high velocity, high violent attack? And where's that tipping point? And secondly, can you define that through a critical success window of, yes, if we had a high velocity, high violence attack, we would be good to fend it off, meaning contain it or prevent it within 14 minutes or less. And if not, what is your critical success window? So to kind of give you a sense of how much this spreads, because we have a very mixed audience, I'm going to share with you a video that shows two computers being attacked by ransomware. Attack will start on the computer on the left-hand side of the screen and eventually make its way to the right. So there might be some music that doesn't always work with presentation, but there's little pop-ups that you'll see come up that explain what's happening. So we're going to just run this. I'm going to be quiet and let you kind of watch the screen. So again, the reason I share that, there's actually two reasons. One is in speaking with people that are IT security professionals that have been doing this for a very long time, I often will ask them, have you ever seen a ransomware attack actually take place? And the answer is typically no, which I think is interesting that as security professionals, we should know what it looks like. And secondly is it really, I think, helps drive home the velocity, right? So less than 2 minutes, we have two computers. Now you may think, well, that's not a big deal. And if you start doing some math, you may think that, oh, well, for my environment, this would take hours to do. And depending on the ransomware, that could be true. But in a situation where you have ransomware, especially today's variants that are using threading, each computer can start to create threads, which means one computer will maybe infect 4 computers, and those 4 will create spawns of threads. So within a minute or two, we would have 16 computers. And then within another minute or two, we'll have 32 and then 64 and on and on. And so within 14 minutes, you can take out literally thousands of assets. And that's kind of part of the germination or the foundation of this critical success window. But think about now, that's just 2 PCs. Think about medical devices. Think about devices that are connected to patients and the impact to them. So again, we get back to how quickly can we respond, and what's our tipping point. We've talked, I think I talked about this in the first session, which was this Vanderbilt University study. So I just want to remind us of this, remind us that any type of cybersecurity attack which has a significant impact on operations, right? That's a significant cybersecurity attack is going to impact patient safety. So we need to kind of keep in mind that the psychological component and assuring that we have the ability to reassure our clinicians and those that are frontline to patients that everything is under control is critical to incident response. All too often, our incident response is just focused on the actual attack taking place, but you need to think about what your ultimate goal is, and that's patient safety. And the most important thing around patient safety when there is a security incident is to keep people focused on taking care of the patients. And if they're more concerned about their personal data, their financial data, the patient's data, can they trust the computers or the devices they're using, which is a big deal. There's a lot of hesitancy as an attack has occurred or after the attack has occurred as to, can you trust the system? And think about what I told you earlier about an attack where the air conditioning system has been taken out and it's 95, 100 degrees, and now you have people in the environment sweating, you have patients complaining. You need to think about those ramifications, not just from an incident response perspective, but a recovery perspective. So impact on patient mortality is job one. And the most important thing you can do from your incident response perspective to help maintain patient safety is to keep your clinicians focused on patient care. In fact, I would tell you probably one of the most important security awareness training tools you can do. I know everybody focuses on phishing and blah, 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 but having a lunch and learn or having a session where you talk to people about this Vanderbilt study and help them understand that your biggest contribution to the well-being of the hospital during a cyber event is to focus on patient safety. And there's a lot of tools with that. They have to check in with each other. Nursing unit managers should know that they need to make rounds and check in on people's ability to stay focused. Those are some important components, and we don't typically connect that with cybersecurity because it's not in your face. It's just tangential, right? We can't feel it, touch it. If there was a active shooter situation, a natural disaster, clinicians are much more focused on patients because they're used to that. You can see it, touch it, and you can understand that. When it comes to cyber, that's a very visceral type of situation. So we have to take the extra steps to make sure that we don't lose focus of patients. And that's a huge piece of any cybersecurity medical device incident response program and recovery program. We've covered this, so I'm not going to go back to it, but obviously the end result here can be the life of a patient. And basically, again, we want to stay focused on preserving patient safety regardless of what else is going on. So we're going to transition into kind of some more of the actual components of a tactical incident response program. And again, a lot of the things that you're going to hear here, you may have never heard before, because I'm pretty sure we're the first company talking about these things. A lot of this, most of it all comes from our Cybersecurity Tactical Operations Center, right, which is the CTOC, what we call the CTOC. for short. It is a security operations center, but the difference is that it is specifically designed to respond to human life events. So it can do what every other SOC does, but typically there's additional protocols that are in place. And what we're going to share with you is some of those things that the CTOC does, so you can use them in your own organization, right? I'd love to have you guys bring us on as your security operations center, but we know that's not right for everybody. So you should scale up yours or figure out how to incorporate some of the things we're about to talk about. So we kind of created this program, Cybersecurity Tactical Incident Response, which I mentioned earlier, called CEDAR. CEDAR has a very rich legacy. When we looked at our CTOC, our Cybersecurity Tactical Operations Center, I know I'm probably getting everybody confused on these acronyms. When we looked at how do we build a tactical incident response program to support the ultimate goal of hoping to protect human life from a cyber attack, we looked to kind of two different areas. But first of all, actually, before we even looked anywhere, we realized that classical incident response, which we talked about, isn't going to work. Right? We can't have these huge hierarchies of, hey, you know, we have an attack and it's impacting medical devices and there's patients connected to it. Well, before we disconnect them, we've got to call, you know, this person and we've got to call that person and we've got to do this. We realized that 14-minute window would have come and gone before we even get the first person on the phone on 2 o'clock on a Saturday afternoon. So we started looking to different industries and organizations that do, you know, manage chaos really, really well. And one of them was trauma centers. We realized that trauma centers do a great job of managing chaos, right? And there's a bunch of, if you study not trauma medicine, but operations on trauma center operations, you find there are some distinct practices that all trauma centers have. And so we really kind of looked at the Shock Trauma Center down in Maryland and what they do. And we realized that there's a lot we can learn from that in our cybersecurity world. And so we took away from that something we call protocols, which I'll share with you in a moment. The second thing we looked at was special operations teams, Navy SEALs, law enforcement SWAT, Green Berets, and really started to think about how do they, you know, how are they good at responding to critical events that have overwhelming odds and yet come out on top, right? And that's what a cybersecurity event is for many of us, is it's an overwhelming event that we have to persevere. So how do we do that when we have limited resources and potentially, you know, shifting priorities and a bunch of other things? So what we found is there's a component within special operations, pretty much all special operations teams have something known as immediate action drills. And so we took these two principles, protocols from the world of trauma and immediate action drills from the world of special operations, and we bake those into our tactical incident response program. So I will tell you that if you want to develop your own tactical incident response program, you need to really think about how you apply immediate action drills and protocols. Protocols are not playbooks, right? And so we depart from that world of classical incident response and really start thinking about how do we respond very quickly to high violence, high velocity attacks. So that's where the legacy is. We then came up with this checklist of different things that we know need to be in this program based on what I told you earlier. When we observe simulations and we see things break down, we realized, okay, we've got to address those very things we're seeing. And so how do we do that? And we do that through this CEDAR program we have. But here are the things you need to think about, right? You have to first and foremost start with the mindset that, and this is hard for many of us to accept, but this is the foundation of what this program and any program related to protecting human life has to be. And that is, you have to have a discussion within your organization that says, we can lose all the data we have, but we can never lose or allow patient safety to be impacted from a cyber attack. If you start with that position, you will then design an incident response program that ultimately protects human life. Are you going to be 100% successful if there is an attack? No, but you will have a higher percentage of success than if you think about this from a, we got to protect the data at all costs. And yeah, if we protect the data, the patients will be okay. That's not a truism. So that's the first thing, is you got to protect human life over data threats. You have to think about the psychological emotional response. You have to build muscle memory, which are what we call immediate action drills, right? We have to think about high velocity, violent, and chaotic cyber attacks, which is why we bring in protocols. ultimately we can't get away from things like HIPAA, PCI, and other frameworks. We have to make sure whatever we build is going to support regulatory requirements and compliance. We need to make sure that whatever program we put in place can evolve as the threat landscape evolves, right? If we see different types of attacks like polymorphic genetic attacks or things like that occur in the cyber world, we need to make sure our plans can support those things. We need to push things to the ground. I'll come back to that in a moment because that's the hardest part about this whole program is pushing things to ground. And it has to be very realistic, right? We have to do something that is using proven approaches, which we believe is the trauma medicine world and the special operations world and the contributions they can make to us understanding how to deal with highly chaotic, overwhelming situations. So let's go back to the on the ground thing. This is a very critical kind of piece to take away. I mentioned earlier that many incident response programs are hierarchical in nature. So I want to talk through how that kind of plays out. Let's just use a ransomware attack, right? Just a generic ransomware attack to keep things simple. And so user sees some form of ransom occurring on their screen, but they don't really know it's ransomware because we really don't show end users what ransomware looks like, right? We talk to them about it and we tell them not to click on things, but we don't really show them the skull and crossbones many times. Or whatever they may see on the screen. So they call the help desk and they are like, hey, something's happening on my computer. And the help desk is like, well, what's going on? And then they try to figure it out and they go back and forth. And guess what? The clock is ticking. Now, all of a sudden, we find out, oh, wait a minute, there's a skull and crossbones on your screen. This is ransomware. Okay, let me notify IT security, right? And then we find out this thing is spreading. We got 4, 5, 6 users reporting the same situation. Okay, we got to shut down this network subnet. Right? Or we've got to do something else. Now, some of us may have automated tools. Some may have automated tools that require human intervention. There's a bunch of things here, but the hierarchical process continues, right? We've got to get more people involved, more decision makers, and blah, blah, blah. But the clock is ticking. And this is one of the most important things about that critical success window is it forces us to figure out what are the key things we've got to do to contain or prevent the attack before it continues to spread to a point where we're in recovery mode. The issue with what I just described to you of this hierarchical thing is obviously the time, but it's also just kind of an archaic practice, right? What we really want to see and what's really important if we're dealing with things like life support or patient safety rather, is the moment that call comes into the help desk, right, or comes into clinical engineering if it's reporting an anomaly with a medical device, is that person has the ability to begin taking action. They can shut down a network segment, the help desk, right? And this makes a lot of people freaked out, right? Like I can tell you, I can't see you guys, but if I was presenting this in front of an audience, which I've done it at HIMSS and some other places, I can see the audience like all of a sudden like, wait a minute, you want my help desk to be able to shut down the domain controller, right? The reality of this is that, yeah, we live in a time where that's your decision. I can't make that easier for you. Right? You can tell me all the reasons why that's not a good idea for you and your help desk and they don't have the level of talent, but that doesn't change the right thing to do. You can explain why you don't do it, doesn't mean it will change reality. And this is probably the hardest part of tactical incident response, but unfortunately, it is the one thing that will preserve human life. You have to be able to respond very quickly and in a way that doesn't require people to get ongoing approval processes. We know people that have automated security in place, but yet you can't execute playbooks or whatever you want to call it, run books, without getting permission from certain people in the organization. You need to revisit that. Now, I'll give you a nursing example and how things should work from the world of nursing and trauma. We'll use your emergency room. And I would implore that any of you that are in IT security, or even clinical engineering, I will tell you this, if I was CIO, I would require everybody reporting to me to do an 8-hour shift in an emergency room. You need to understand how they operate in order to not only complement what they do, but to take practices away from them when it comes to things like incident response. So let's think about a patient that comes to the emergency room who's got chest pain, right? So they have chest pain, nausea, pains radiating down the left arm. So classic signs of an AMI, acute myocardial infarction, or what we typically call a heart attack. The nurse that is going to interact with that patient is going to do a few things. They're going to potentially administer aspirin. They may determine the patient needs nitro. They're going to draw blood. They're going to get a chest x-ray. They're going to get the patient an IV. They may do a calcium supplement. There's going to be a variety of things that take place, right? The x-ray, the radiology department's going to come in. The respiratory therapy may come in if we have issues with breathing. The point of this is that at no point in time in all of this care that's beginning to happen is a doctor called in. We don't have the situation. If IT was running the emergency room, here's what would happen. The person would come in with a heart attack. The nurse would go to the person and say, okay, wait, I got to go check with the doc and see if I can give you aspirin. I'll be right back. Then we're going to go figure out, like, should I start an IV? And then go talk to the doc and come back. But that's not really what happens in an emergency room. There is a lot of delegated on-the-ground authority. And to do incident response for medical device security and patient safety, we have to become comfortable with pushing this kind of authority and decision-making down to the ground. Unfortunately, for many of us, our help desks aren't where we invest the most time, right? We don't have the most high-paid, educated resources, and we've got to think about this because they are the first line of defense. The clinical engineering on the other side, you know, the challenge there is many times when we speak to clinical engineering, they have no training in IT security, and we kind of get frustrated with them because they don't quote unquote get it. But they also, this hasn't been their life. Like IT security is not clinical engineering's primary responsibility and has not been classically, right? That's not where they focused. So we have to correct these things, and that's why we put this on the checklist. So hopefully this is helpful and gives you some constructs of what to think about. When we're thinking about tactical incident response, this is kind of the strategy that we like to see. This is what we use. Our first goal in our strategy, right? This is not the actual steps. This is what we want the outcome to be, is we want to make sure we can contain the attack. And that means the velocity has been driven to zero and the violence is neutralized. What do we mean by that? The attack's no longer spreading and nobody's at risk, right? We've reduced that down. So that's our first strategy, the first goal, contain this attack. There is a point in time where you will need to make a decision that we can't contain this. We don't have enough resources, tools, it's too sophisticated, it's getting ahead of us. So that moment that you feel that, understand that, or realize that, and this is to go back to that simulation stuff I told you about in the beginning of the presentation, that's where people tip, right? Where we start turning up the heat in a tabletop simulation and we start seeing that the attacks are getting ahead of them and the people around the table are starting to fall apart. And the reason for that is they have nowhere to go. They're trying to just contain. You have to at some point make a decision where you're going to prevent. And that means you abandon the containment, or if you don't have enough resources, you can try doing both at the same time, but most places don't have enough resources to do both. And you decide, I'm going into prevention mode. I'm going to start shutting things down in order to prevent them from becoming a victim of the attack. And that could be taking patients off of devices, right? So you start with containment. If you can't contain, you move to prevention. And that has to all happen within 14 minutes. It's not like I got 14 minutes to figure out containment and then 14 minutes to figure out prevention. No, you've got 3 or 4 minutes to figure out containment, and then you better decide whether or not you're going to be doing prevention. Once you have instituted containment and prevention and achieved one of those, you then can figure out how this attack started, which is what we call resolve, and hopefully stop that from being able to be done again, because we don't want the attacker to repeat. And then we reset. This is the last stage of our strategy, which is, okay, let's get ready for the next attack, right? At the end of reset, we start recovery. So that's how those things break down. Again, these are kind of the strategies that we look at from a kind of what are we trying to achieve perspective. So this kind of translates into this life cycle, right? We're going to triage the situation, the attack. We're then going to decide, are we containing, preventing, or resolving? And can we do those things in parallel? If we have enough resources, we would train ourselves to do those things in parallel. The reset is then the aftermath, right? The kind of like get ready for the next thing. And you may see in here that there's no lessons learned and all of that stuff you would see in a classical incident, and that's because it's outside of the scope of this. We're just trying to deal with the attacker straight on and get things back to normal. We'll come back to this in a few moments. What I want to start introducing you to gently is protocols, right? The first protocol I'm going to share with you, and some of you may be familiar with this, is something called SecCon. It stands for Security Condition. Not a lot of organizations use this. I think it's a mistake. It takes a little bit of time to put in place, and obviously we don't all have a lot of time, but I would tell you it's It's worth doing because especially if you have the more limited resources you have, the more important it is to do SecCon. Interestingly, because you don't have a lot of resources, you put off doing this. What I would tell you is try to do what you can to put SecCon protocols in place, and I'll take you through what they are. Long ago, there was a movie called War Games, right? In the movie was about these kids who hacked into a computer and set off these defense conditions, or what we call DEFCON. And DEFCON goes from 1 to 5, right? So DEFCON level 5 is what we are at peacetime. DEFCON level 1 is there's actually nuclear wars imminent. And you can go in between 5 and 1, right? But the more important thing to think about is when you go from 5 to 4 for DEFCON, there are certain things that get triggered in our national defense policy. So for example, if we go from 5 to 4, all leave for military personnel is canceled. They have to return to base. You know, we may move assets, bombers and ships and other things to strategic geographic locations. So the point of this is it's all pre-decided, right? Like, hey, we can move very quickly and get resources involved without everybody having to be told what to do when the incident's actually occurring. So that's what DEFCON really does. We've taken that thinking and applied it to SecCon, security conditions. So SecCon is the same similar thing. We have SecCon, you see InfoCon, that's the old name we used to use, but SecCon level 5, which is what pretty much all of you are right now. You're all at condition green. You're all normal day-to-day operation. You can go from 5 to 4, which is, hey, there's an increased risk of attack. Maybe there's some threat intelligence that comes out. Maybe you learn you got vulnerabilities or some risks. So you move to level 4. And level 3 is there's something specific against your organization. I'm jumping to level 1 because this is where there's actually an attack right now. Velocity is high, violence is high, the attack's moving, we're tactically responding, and in terms of our incident response plan. And level 2 is the attack's already occurred, right? It's in the past. We now figured out, wow, somebody attacked us and they took all our data or they did something. So all of this translates to specific activities, right? You look at level 5 and you go, hey, if we're at level 5, this is what's occurring. But let's look at like level 3. So level 3, we know we have a specific risk, and so we may have a plan for looking at specific risk mitigation, right? Level 4, increased risk, maybe we're going to remove backups. We're going to take backup off site. The idea here is that you've pre-decided if you go to any of these conditions, here's what you're going to do. We've seen this actually deployed at a few hospitals, and the most advanced versions of this can be executed by the help desk, right? So a ransomware attack comes in, they're dealing with the ransomware, they go, hey, we're at SecCon level 1, and that sets off a whole bunch of processes without having to make 20 different phone calls. So I'm introducing you to this because if you're going to think about life safety, you need to think about what are the pre-staged activities that you're going to set off if you realize we have an attack and we have a potential life safety issue. How are you going to mobilize your resources at 3 o'clock in the morning, right? Who's going to be available and what things can you actually put in place or think of ahead of time? So that's kind of SecCon. Let's skip through these. That's just a spreadsheet you see on the screen of how this kind of works out. So SecCon is kind of the precursor to what we call the rapid response protocol. The rapid response protocol is a catch-all protocol, meaning we designed this because we have clients who are like, well, can you just give us a basic protocol that we can follow? Because we have protocols for a lot of different things at the CTOC, right? Not just one, but we tried to come up with one that most people can use or you can begin to customize. So the protocol at the highest level has a triage component, which is what's going on, right? And this is typically going to be done by either clinical engineering or your help desk, depending on where that call comes in or where the alert generates. And it could be a SOC if they're seeing the alert, but we're kind of playing off the idea that somebody's picking up a phone, calling the help desk or calling clinical engineering. First thing we're going to do is triage. Once we get triage underway, we're going to be getting into our contain, prevent, resolve, which is our strategy. And then we're going to reset, right? So that's kind of the cycle. So how does this kind of start building out into an actual protocol? What I want to do is take a pause for a moment, because one thing I've learned is that you can't be successful in a medical device incident without your clinical rapid response team being involved. And I also didn't realize this, but I didn't realize that many people in IT don't know what a clinical rapid response team is. I've been given talks like this for years now, and it took me like 3 years before I realized people were quizzical when they were hearing me talk about this, and I didn't think it was because they didn't know what a clinical rapid response team is. So I'm going to spend a moment to explain what that is. If you already know, please just bear with me. A clinical rapid response team is a group of physicians that typically CMS and I believe JCO require hospitals to have 24/7. And they are alerted for very critical situations in the hospital related to patient care. So for example, a patient starts showing signs of a stroke, a patient starts having seizures, a patient starts having signs of cardiac issues. This is the team that's going to respond. And there's usually going to be 1 or 2 nurses, a physician, respiratory therapy, radiologist, and maybe 1 or 2 other people will be involved. And so you'll hear over the hospital speakers, right? Like you may have different names for this or different codes, but usually it's going to be rapid response to 4 South room 20 or something like that. And this team will go. The reason I'm bringing this up is because you need to think about, you have an attack against medical devices. How are you going to activate your rapid response team? We're thinking about this 18 months down the road. You know, we don't want to have in a court of law is somebody testifying that, well, we were trying to figure it out and we were taking steps to prevent the attack from spreading. And I ask you as an attorney, which I'm not, but if I were, I would ask you, well, what were you doing to care for the patient? And you're going to probably look at me blankly unless your answer is, well, part of our protocol, our security condition, is the moment we believe there is a significant risk, we dispatch our critical rapid response team to the bedside. That's the right answer. And that's why I took you through SecCon and why I'm taking time to do this. You have to integrate that team, right? So you have to assure that your IT security, clinical engineering, and clinical rapid response team all have an understanding of your response procedures, your protocols, training, and simulations. Now you see the word training in red because a lot of times when I'm working with organizations, they tell me about tabletop simulations. And when I ask them, well, what training have you done? They're like, well, we do tabletops. Okay, but what training? Well, we do tabletops. Tabletops is not really training. Tabletop is a test, right? It's your final exam. So imagine you going for some type of certification or degree, and you basically come into college or school or wherever you go, and they just throw a tabletop at you that you should have known everything taught to you at the end of a semester. You have to do training, and that training should be logged, and hopefully you have documentation and materials that if you go to court, you can demonstrate that, yes, our team was trained. We go through 8 hours of training a year, and we also run simulations to test for their ability to apply the training. So that's why I'm pulling that out, because again, we're trying to reduce liability, increase defensibility, as well as respond in a professional and timely manner. So you got to get all these people to work together as part of a single incident response, and especially your help desk, right? They need to be a big part of how this is going to work, or clinical engineering. We've kind of gone through all that, so I'm not going to cover that. So this is how the protocol actually looks. What you see here is qualify, which is another word for triage. And so if I'm on the help desk or I'm in clinical engineering, I need that team to ask these questions. They need to decide, is this a real incident based on what I'm being told? Is it a security incident or issue? You know, and is there life at risk, right? Is there a patient connected? We need to get them to understand how to do that triage. They then need to categorize what type of attack are we seeing? And that's going to set off a response, right? And then they're going to focus on contain or prevent, and then they're going to reset their posture, and then they're going to reset. So this is what the protocol looks like. We don't have enough time to go into all of this, and I'll give you some hints on what you can do about that in a moment. You see 2A, 2B, 2C. The idea behind that is if you have enough resources, you can do these in parallel, right? You can have a person on the help desk categorizing, they can set off an alarm, rallies IT security, they start containment, and posturing is getting the security conditions up and running. If you don't have the resources, you can do these in order, right? 2A, 2B, 2C. So that's kind of how that works. But you can take this basic protocol, what we call a rapid response protocol, and customize it for anything, right? You can use it for things other than just life support. You can use it for pretty much any kind of incident you want. So how do we manage this? I'm just going to go through this real quick because we're running out of time. One thing I will tell you is the response level agreement. We talked about that. Like, what is your critical success window or target? driving things to the lowest level possible, declaration, the ability for people that take action. We're going to skip call the ball. Two things you have to do in the incident, especially when we have life safety involved, is journal management and tracking state. So journal management is just having a journal of the incident. Our platform includes an incident response component, right? If you deploy our software as part of our offering, you get an incident response tool. So here is an example on the screen of the incident response tool. I don't have other tools to show you, and we're kind of partial to ours. So, but I'm going to point out, if you want to do this on your own, what you need to have in your journal. And again, we're thinking about what happens 18 months down the road when people start asking a whole bunch of questions of how we manage this incident. So we want to have an incident timeline, right? We want to make sure that every second, every minute, we are able to account for what actions we took. So we want to make sure that that's called out, that we can see that timeline, and that hopefully it's visual if possible. We want to have artifacts, right? We may have screenshots, we may have logs, we may have communication with the attacker, we may have other pieces of data that need to become part of this journal. So you need a way to upload it. You need to describe who is the team that was involved in this. We need to track our lessons learned. And we need to do something we call things we know, things we don't know, which I'll explain. So tracking state, when you're trying to figure out what is our next step, right? We talked about in simulations, people falling apart. Again, it's because they don't have tools. So one of the things you can do is this concept of things you know, things you don't know. It's real simple. You can do this on a piece of paper, right? You can do it on a whiteboard. And this is how we manage our incidents, right? Is we think about continually every second of that incident. What do I know? What don't I know? What you know is anything that's validated, right? Anything that's not validated or you don't have a definitive answer for is something you don't know and needs to be assigned to somebody to go do, right? But this helps us kind of start understanding where we are in an incident, prioritizing how much work we have and how many more resources we're going to need. It's extremely powerful. It sounds silly and simple. I can tell you, we can see the before and after. When we have a simulation, people don't know about this. They go through, they reach their tipping point. When we give them these kind of tools, they're able to respond more effectively for a longer period of time. So we just talked about that. Other thing you need to have, we talked about this in the detect module, is asset valuation and high value targets. Asset valuation is, we define it as a 1 to 5. 5 is a life support asset. 1 is the lowest level asset in an organization, like a printer. High value targets are those things that represent the attacker's perspective. These things are critical to be able to define, because as you're doing that triage as part of your protocol, you need to determine, am I dealing with an asset value 5 here, or asset value 3 or 1? And that's going to shape your response. Within our platform, we actually have a way to declare that. So you can call out if it's what the asset value is and if it's a high value target, and the correlation and alerting engine actually and the machine learning stuff all play off of that. All right, so that's everything I had. I know it's a lot to throw at you. A couple real quick housekeeping things. If you want a copy of the field manual, it's free, please reach out to us. But most importantly, we threw a lot at you today, and we've realized there's no way to give you this entire module I just gave you. Everything we went into typically takes 3 days. Day 1, we go through all the incident response concepts. It's all education and training. Day 2, we go into how to manage incidents and how to do tactical forensics. And day 3, we just do simulation, right? So typically this program is somewhere around 20 grand. It depends, and it can be more depending on the size of the organization and the customization. So what we're going to try to do, if you guys are interested, you can get this for a lot cheaper, I guess, just being frank, for a pretty limited time, probably over the next 30 to 60 days. There's a link in the chat window. If you go to that link, it's not to register, it's just, hey, yeah, I think I'd like to get more information, and it's cool that you're giving us a discount. So I'd like to think about, could I bring this program to my organization? Some of you are rather small. So what we've thought about is, hey, if you're a smaller hospital, right, like a critical access rural hospital, and you can get a bunch of hospitals together, then you can split the cost amongst you, right? And we can figure that out. So we're trying to find a way to get as many people trained on this. And we do this in person, kind of can sort of do it virtually, though it's a lot to do virtual. So if you're interested, please reach out on that. More importantly, everything we've talked about over these 3 modules, these 3 sessions, is included in our medical device security platform. Everything from the detection to the policies to the procedures to the incident response to every aspect of what we've talked about. In fact, as best we know, it is the only program in the market that has everything fully integrated, back end to front end, and you can get deployed in less than 30 days, literally. With that, hopefully this was helpful. Please keep an eye out. We'll be doing further education sessions into the fall and winter on some other topics. If there's anything we can do for you, please reach out to us. Hope you take advantage of the incident response training program. With that, Laura, are there any questions or?
We don't have any questions.
All right, well, thank you so much, everybody. Look forward to hopefully getting to know you and hear from you. Thank you so much and take care.